Hello, everyone. Today's lecture is about classes and objects in Python. So what is a class? A class is some type of structured data that some different types of objects belong to. So remember in Python, everything is an object. So an example of a class could be like a car. In a car, it's got some object that defines the wheels and some object that defines the color and etc. And you could make these as complex as you need to fit your use case. That would be like a user-defined class, but a built-in class in Python. Int is a class that defines the int object. Same thing with float, string, bool, list, and tuple. Since everything's an object, everything is defined by a class. They're like the blueprints to make objects. So an object then is an instance of a class. So you have the int class, and then when you actually make an int, say the number 7, that number is an object. Here we go. For example, 1 is an instance of int class, or true is an instance of the bool, etc. Again, everything is an object in Python. So to create an object, this is the syntax: object name equals class name, and then the arguments that the class requires to construct it. So we haven't seen the syntax for creating an int yet, but an int equals int with the string 1. Actually, I guess we did see this in one of the earlier labs where you're asking for user input. What you're really doing is you're taking that user input, which is a string, and then you were calling the int class constructor. That's what this is called, is the constructor, to create an int object from that string. Here you're creating a tuple from a list, and then down here you're creating a list from a tuple. So you can also define custom objects. The names of custom objects are in camel case. That's capital first letter of each word, as opposed to what we've been doing is underscores to separate. That's called snake case. So for example, we can make a point class, a circle class, a car class, anything that you want to represent a physical thing, you can create a class for in Python. So we're just going to take these over to the Spider IDE and mess around with them a little bit. Let's see what's up next. Yep. So copy these into the IDE. Nope. Sometimes when you copy and paste, it messes with your indentation, so always good to double check. We're inside the class scope here, and these need to be also members of the class. So we defined our class. We have a docstring for our class. That's very important. Say what the class does, just like a function docstring. And then here under the attributes section, we say what attributes this class has. So a point has an X and a Y. Can access them with self.x and self.y. That's to access the actual versions in the object. And then we define a method setX, so we can have our point in setX, and we can set y as well. So I'll come over here into the if name equals main block. Oops. We're going to say our point is equal to points. And here it pops up our docstring, which is really helpful for us to remember what goes into this. So we'll say our X is equal to 5 and our Y is equal to 10. We can print out our point and see what that gets us. Cool. So what printed out was, it said we have a point object at, and then this is a memory location. So this representation is not super helpful to us. So since everything is an object, everything is originally a class in Python, all classes have some built-in methods that we can then override. So what's happening here is when we print out our point, it's calling the representation method. which is looper. We don't need a doc string for this one. This just returns what we want printed out instead. So we'll print out point at and then it's X and Y. So what happened here, this is a F string or format string. This is a bit, we haven't gone over this yet. You can just trust me that it works. But what's happening is you put the F before the quotes and then it evaluates your string. And then when it gets to the curly braces, it thinks, okay, I'm gonna actually evaluate this expression as though it were Python. So it's equivalent to writing, point at plus self.x plus space, comma space plus self.y. This does the same thing. I find that this is more readable and it's easier to remember to put the spaces in. So you'll see me using F strings for most things from here on out, and you're welcome to do the same. Great, so we can print our point and we get a helpful description of what our point is. We can also print just the X coordinate. That's 5. Same thing for the Y or any attribute. And so that's most of the main stuff you can do with the class. Let's go back over to the lecture. So to access attributes and methods, we just went over that point 1.x. Oh, we didn't see the set x, so let's look at that. So we've got our set x method and our set y to modify the value of x. So we've got our point at 510. We'll print our point dot x, and we'd expect this at this point to be 5. Then we're going to call set x on our point. Set x, and we'll set it to 123. Really move that point. Now we print our point dot x again. So what do we expect the second print to return? I think it's going to print out 123. I would hope it does. That means everything's working correctly. Awesome. Prints out 5 the first time because our point was initialized with 5 for x. And then we set x to 123. And then when you print it out again, it stores that. It modifies this x variable inside our instance, our point. And then when we go to access that again, with printing out our point.x, we can see that that state has been maintained. Now we can also nest this, and we could create a circle class that uses point as part of as one of the objects that it stores. So you can have classes that store classes that store classes that store classes, all the way down as many levels as you want until you get tired of it. Don't need to import point because it's directly above. So walking through this, we've got a circle, which is defined by a center and a radius. Pretty easy shape geometrically. It's just one point and one float. Now we've got a set center, which is going to set where the center of our circle is, and that's a point. And then we also have set radius, which is just going to modify this float radius to change the size of our circle. So when we create this, we could say our circle 1 is circle with our center is a point. So let's try our point, and then the radius 10.3. No units on that. That's okay. Now we print out the center of our circle. So our circle 1. Take a moment to think what this should print out. So it's printing out the point. Here, these are distracting. Get rid of those other print statements. Now we've just got the 1. It's printing out the point. And since we overrode how we want points to be printed with this representation function, when it prints out the point, the center point from here, it's going to then call this function on our point and say, okay, here is point at 510. Now we can create this with a variable point that we've already defined. We can also, create it with an inline declaration. Our circle 2 very different circle, and we're going to print our circle 2 dot center. So we can see that it works just as well if we create a point here, like create the point inside while we're creating the circle. That's totally legal. It's up to you which one you think is more readable. One distinction is what happens if we try to change the center by modifying our point out here. So we'll set the x to 123. Then we print our circle 1 dot center. Let's take a moment to think what we would expect to happen right here. So since our point is an object and circle is just maintaining a reference to the object, it's just saying, okay, I've got this point object over here somewhere in memory, it's being stored, and then we go and modify that point up here, then it actually modifies where our circle is centered at, because our circle is still centered at our point, but our point has moved to a different spot. So now when we print out the center of our circle, it's at 123.10. Versus for this one, there's no way to modify where this point is other than replacing a new point. So we could say another way to change this would be our circle 2 dot set center. We've got to pass in a new point, so we'll go point 23, 15. And then we'll print that, so that should replace the center. So this is our circle 2 at the beginning. It's at 1014. 1014. And then we set the center to 321.15 and then print it out here. The benefit of doing it this way with the inline creation and everything is that it's very clear what we're doing. It's very clear that we're moving our circle. But when we do this, it's not as obvious that we're moving our circle, especially if there was a lot more code in here. It could be really easy to lose track of what's happening. Back over to lecture. Accessing the attributes and methods of the circle. With this, we just saw 2 ways to create. So that's everything on classes and objects. There's lots of other information online and in the book, but that should be everything you need to get started on the next slide. All right, thanks everyone, have a good one.